Addition and subtraction rules. There are many rules or formulas that you could learn, memorize in trigonometry. In my opinion, it's best to remember as little as you need to. You should know that the sine of x plus y is the sine of x cosine y plus the sine of y cosine x. You should also know that the cosine of x plus y is cosine x cosine y minus sine x sine y. Definitely know these two. Now, there's two more. There's two more that we could talk about. What if that plus sign was our minus sign? Now, if you have a minus b, like 7 minus 9, so this means 7 minus positive b. Just like this means 7 minus, well, that number is positive. There's a rule for addition and subtraction. You can change the operation to the other as long as you change the sign of the second number. This is the same as 7 plus. I changed that and I'm about to change that. You can change subtraction to addition anytime you want. So, if you wanted to know what the formula for the sine of x minus y, and you only remember it for sum, you don't need to panic as long as you know one other thing, or two things. That x minus y is x plus negative y. So using the rule above, this is the sine of x, cosine of negative y, plus the sine of x. I meant to say plus the sine of negative y times the cosine of x. Now the other thing you have to remember, and I'll even give you a way out of remembering this, is that cosine of negative y is just cosine of y. And cosine of x doesn't change, but the sine of negative y is negative the sine of y. This minus comes out in front. So, we have that this is equal to that. And we derived it pretty quickly. Now, another way to remember is, if this sign is plus in the middle, then it's plus. If it's minus in the middle, then it's minus. Okay, so you can remember it that way. Sine of x minus y is the same as that, except the sign in the middle is different. That's a nice way of remembering it. Minus sine y cosine x. Now, what about the second formula? What if you have the cosine of x minus y? You can think of x minus y as x plus minus y. That's the first angle, that's the second. The rule says that the cosine of a sum, well, is the cosine of the first angle, x, times the cosine of the second angle, minus the sine of the first angle, times the sine of the second angle. Well, cosine x doesn't change, and cosine of negative y is just cosine y, minus the sine of x doesn't change, But the sine of negative y is negative the sine of y. Okay, all that happened is the sign in the middle changed. So if you remember these two, then pretty much for free, as long as you remember one little thing, if you remember these two, if the sign in the middle becomes negative, then those two signs change from the original. It used to be plus for sine, now it's minus. When you have cosine of x plus y, it's a minus. You go to x minus y, the sign changed. I would remember that. Now, I like to have these two formulas in front of me, especially the ones on the left, so I can figure out what tangent is. The tangent of x plus y, there's a formula for it, but do you want to remember it? How about you just remember that tangent of any angle, including x plus y, is the sine of that angle divided by the cosine of the angle. That is, it's sine of x plus y, which is the very, very top equation on the left, divided by cosine of x plus y, which is the second equation on the top left. And now you have a way of calculating the tangent of x plus y and all you have to do is remember that tangent of an angle is sine of that angle over cosine of the angle, and just remember these two equations. For the record, this is equal to the tangent of x plus the tangent of y over 1 minus the tangent x tangent y. Why you would spend your study time remembering that formula that I just wrote is beyond me. Spend more time memorizing these two and remembering that if you go from a plus to a minus, then that sign changes. It was plus, now it's minus. If you go from plus or minus, you remembered that it's a minus, so when you change from plus to minus, the sign changed as well. Okay, this formula is good enough. Now, what about the tangent of x minus y? Well, I'll just write it down here. That addition becomes subtraction. Addition becomes subtraction. And the sign in the middle changes. Becomes minus. And in the bottom, the minus becomes plus. And both of these signs change. You want to remember that? That's fine by me. Okay. Now, what you need to know is the following. You should know this table. 0 degrees, well, we'll come back to 0. 30 degrees, 45 degrees, and 60 degrees. What other angles have those as reference angles? Let's look at 30 degrees. in the first quadrant, if I drew an angle, always go down to the x-axis. This is 30 degrees and that angle is 30 degrees. Let's draw an angle in the second quadrant. Always go down to the x-axis. If this angle, the reference angle, is 30, well then how big is this angle? Well, there's some things you just have to know in trigonometry. For example, you can know that you have to know that's 180. And you go, oops, I went a little bit further than I wanted. I went 30 further. So I have to go back 30, and you learn that that angle is 150. So 150 degree angle also has a 30 degree angle. What about in quadrant 3? I draw any angle, and I always go to the right, to the x-axis. And I want that to be a 30 degree reference angle. Well, how big is this angle? Well, up to here is 180, and oh, I'm going 30 more. 180 plus 30 is 210. So 210 degrees has a 30 degree reference angle. What about in quadrant 4? Always go to the x-axis. This angle is 30 degrees. Well, I don't know what that is. That's what I want to know. But you know what? If I go a little bit too much, I win 360, and then I have to go back their extra amount I win, which was an extra 30 degrees. Oh, 330. Let's play the same game with 45 degrees. Let's find out what the reference angle is for 45 degrees. What in each quadrant? If in quadrant 1, the angle here is 45, well then that angle is just 45. But what if I'm in quadrant 2 and the reference angle is 45? We want to know how much that is. Like, I don't know. Teacher mentioned it a lot, but I forgot. Well, go too far. Go out to go out to 180. Go to 180 and then go back to 45. Because then you end up here. You only really went that far. And you're like, oh, that's perfect. That's exactly how far I wanted to go. So you get 135 degrees. What if you are in quadrant 3? Well, and your reference angle is 45 degrees. Well, starting at the x-axis, you go 180. You just have to know that. Plus 45. 180 plus 45 is 225 degrees. Now, what if you're in quadrant 4? Same reference angle. Well, you can go all the way around. That's 360 and say, oops, I overshot where I wanted to go. I only wanted to end up here. So, you come back 45. What that means is you really only went that far. And it turns out that that's 315 degrees. 60 degrees. In quadrant 1, I draw an angle and I complete it with a third side making a right angle. This reference angle is 60. So that angle is 60. Well, I already have that. What if I'm in quadrant 2? I want to know how far that is. And again, this is 60. Well, you can call it x. Do a different method, call that x. And you know when you add 60, you get 180. X plus 60, this is x. And I add 60 more, so I get 180. Well, if you take away 60, the angle you want is 120. What I've been saying earlier is your goal is only to go up to here, but you make a mistake, you go too far, you went 180, and then you go back 60. Okay. What about if you're in quadrant number 3 and your reference angle is 60 degrees? So my goal is to know how big is that angle. Well, I know if I start here, up to right here is 180 plus 60 more. I can handle that. And you get 240 degrees. And one last one. Let's clean this up a little bit. You are in quadrant 4 with a reference angle of 60. I want to know how far that is. Well, if I go all the way and then I take away 60, I will only be here. But that's where I want to be. That's 300 degrees. And the other one is going to be 0, 90, 180, and 270. If you go up to here, or if you go up to here, that's 180, or you go up to this axis, 270, and or if you don't go at all, you stay right there, that's 0. This table is very, very important if you want to use the sum and difference to find the sine of, say, 15 degrees. Using any one of these numbers, using any two of these numbers, any two. Doesn't matter which two. Can you find a sum of any of those two numbers or a difference of any of these two numbers that sum or differ to 45? Now, let me just have the formulas in front of us. The sine of x plus y, this is the sine of x cosine y plus sine y cosine x. And the cosine of x plus y, this is cosine x cosine y, I guess minus sine x sine y. So question is to find the exact value of sine of 15. And this table to the left is very important. You need to have this table in your head. Which pair of numbers add up to 15? Since all the numbers except 0 are bigger than 15, I doubt you're going to find the sum that add up to 15. But you know what? 45 minus 30 is 15. And for the record, 135 minus 20 is 15. 60 minus 45 is 15. 315 minus 300 is 15. There's a lot of 15s going around. 150 minus 135 is 15. 330 minus 315 is 315. We will use 45 minus 30. So we're going to use the sine rule, but since that formula on top has a plus, but we have a minus, we know that that sign will be different. So that's x and that's y. It'll be the sine of 45 degrees, the cosine of 30 minus the sine of 30, the cosine of 45. Now, we know the trig functions for a 45, 45, 90 right triangle. The sides of the triangle are 1, 1, square root of 2. For 30, 60, they're 1, 2, square root of 3. The sine of 45, well, let's use this angle. It's 1 over square root of 2. The cosine of 30, it's the square root of 3 over 2. The square root of 3 over 2 minus the sine of 30. There's 30. It's opposite over hypotenuse. The cosine of 45 degrees, that angle, even if it is adjacent over hypotenuse, 1 over square root of 2. Even if you use this angle, that's the adjacent over the hypotenuse. Either way, it's 1 over square root of 2. They have common denominators. The first fraction is square root of 3 minus 1. 1 times square root of 3 is square root of 3. 1 times 1 is 1. And the denominators are the same. That is one way of writing the exact value of the sine of 15 degrees. There is absolutely, assuming I didn't make a silly error, there's absolutely no error in that answer. That is, it's not really close to the answer. We didn't approximate. We didn't round off anywhere. Again, minus any silly error I made, that is the exact answer. 100%. Okay. Again, I love to have this table in front of us. And the two formulas at the top. If you were now asked to find the cosine of 75 degrees, well, you want to write this as a sum or difference of numbers in this chart. Well, I just happen to look right here and I noticed that 30 and 45, they add up to 75. And for the record, 150 or 225 minus 150 is 75. You can use that formula. 30 plus 45. So that's the second formula, and I even have the plus, so I don't need to change that sign. It's the cosine, we'll call that x and that y. It's the cosine of 30, cosine of 45 minus the sine of 30 times the sine of 45. Well, the cosine of 30, I drew on this a bit. Let me rewrite them. So, here is our 30 60, 90 right triangle. This is 1 and 2 and square root of 3. And the 45 is 45, 45, 90. It's 1, 1, square root of 2. The cosine of 30, that's adjacent over hypotenuse. The square root of 3 over 2. Times the cosine of 45. It's adjacent over hypotenuse. 1 over square root of 2 minus the sine of 30. It is the opposite over the hypotenuse, or half. The sine of 45 degrees. It's the opposite, which is 1, divided by the hypotenuse. 1 over square root of 2. Once again, we have 2 square root of 2's. The numerator is square root of 3 minus 1 times 1 is 1. That is the exact answer to cosine of 75 degrees. Suppose now we want to calculate the cosine of pi over 12. The cosine of pi over 12. Well, maybe the first thing you should do is realize pi is 180. You divide it by 12, and you get 15. So basically, we want the cosine of 15 degrees. Well, we just found the sine of 15 degrees. You know, we can use 30 and 45. This is the cosine of 45 minus 30. So we're going to use the second formula, but we have a minus here. And our formula that we memorize has a plus. So that means that sign in the middle is going to be wrong. So we get, and this is x and y. So we get the cosine of x, which I write 45, the cosine of y, plus the sine of x times the sine of y. But we know all of these answers. The cosine of 45 degrees using the triangle on the bottom is 1 over square root of 2. The cosine of 33, the cosine of 30 is the square root of 3 over 2. Plus, the sine of 45 degrees is 1 over square root of 2. And the sine of 30 degrees is 1 over square root of 2. So we get square root of 3 plus 1 over 2 radical 2's. Suppose you want the sine of 75 degrees. Oh, I don't like that one. Hold on a moment. The sine of 195 degrees. Now, using the numbers in this table, you want to find two numbers that either add up to 195 or subtract to 195. Well, I happen to notice that these two numbers add up to 195. Good luck finding that if you don't have the table in front of you. Now, before we go, it's all good. I wrote it down so I won't forget. Before we go on, let's see how I can show you quickly how to write down the answers to the table. Okay. If that's 30, you get 30. If this is 30, it's 180 minus 30, 150. If you go to there and it's 30, it's 180 plus 30, 210. If it's 30 here, it's 360 minus 30, or 300. Okay, I got that one pretty quickly. 45. Basically, so you just have to be good with the math. If that's 45, well, it's 45. If this angle is 45, well, you're 45 less than 180. Do the subtraction. This angle is 180 plus 45. That's 225. If this angle here is 45, this is, I don't know. Oh, I'll go 360 and take away 45. Okay. It should take hopefully less than a minute. Having these numbers in front of you will really make life easier. 60 degrees. If you're in quadrant 1 and that's 60, well, that's 60, which I have. If you're in quadrant 2 and that's 60, well, this is almost 180. In fact, it's 60 degrees less than 180. Quadrant 3 is 180 plus 60, 240. Quadrant 4 is almost 360. Oh, it's 60 degrees less than 360. Here's my table, and for completeness, the multiples of 90s, or 90. Okay, there's your table, and fine, I'm probably better in arithmetic than you are, but, I'm able to generate this table without having to talk, etc., in probably 30 seconds. You should be able to do it in a minute. I would not take an exam on this type of problems without this table in front of me. Trust me, the 2 to 5 minutes it's going to take you to write the table is going to save you time when it comes to trying to figure out two numbers that sum or subtract to 195. Well, we said that we're going to use 150 plus 45 plus. So it's exactly the top rule. No sign change. So this is x and that's y. It's the sine of x times the cosine of y plus the sine of y times the cosine of x. Okay, well, let us find the cosine of 45 degrees. The cosine of 45 degrees, using this angle, is adjacent over hypotenuse. It's 1 over the square root of 2. The sine of 45 degrees, same thing. So opposite over hypotenuse. 1 over square root of 2. What is the sine of 150 and the cosine of 150? Well, 150 is a little bit short of 180. In fact, it is 30 degrees short. Not taking into account immediately plus and minus signs, that's what we get. since this is going up, it's plus, and this is going to the left, it's negative, and hypotenuse is always, always positive. Using this triangle, the sine of 150, it's the opposite over the hypotenuse, plus the cosine of 150, it's adjacent over hypotenuse. It's negative the square root is 3 over 2. So once again, the bottom is 2 square root of 2. The numerator is 1 minus, because that comes out as minus, or a positive times the negative is negative, and 1 times square root of 3 is square root of 3. That is the exact value of the sine of 195 degrees. Let's finish up this video by trying to compute the tangent of 255 degrees. Now, probably the first thing you should do, so like I said, well, maybe I'll change it to tangent if I didn't say that. The tangent of 255 degrees. Well, like always, I know I didn't do this, but it's more than, actually, it's not 270. It's 180, 225, I meant to say 255. It is 75 more than 180. Well, that's a problem because you go 180 and 75 more. Well, that means that angle is 15. Okay, and we don't know the 15-degree angle. So we need to use sums and differences. Which pair of numbers add up to 255 or subtract to 255? And let's see what pair I can find. Okay, it looks like these two numbers add up to 255, excuse me. So, again, without this table, you know, what if in your head you're trying to do this and you never say 120? How else are you going to get 255? I mean, maybe you'll hit on 30 and 225. Okay, but maybe you won't. 255, we're going to say is 120 plus 135. Okay, now either we use the tangent formula or we don't use the tangent formula. Okay, if you don't want to use the tangent formula, just remember that this is just the sine of 120 plus 135 over the cosine of 120 plus 135. Since it's plus, we have those two formulas right here. In both cases, x is 120 and y is 135. So the top is going to be the sine of x times the cosine of y plus the sine of y times the cosine of x, all divided by the cosine of x times the cosine of y minus the sine of x, the sine of y. And we need to know the sine and cosine of 120, and we need to know the cosine and the sine of 135. So I do have a couple of typos. Y is 135, so I shouldn't have y here. I should have 135. And over here, underneath that, I have 13y. That should just be 135. So I need the sine and the cosine of 135 in a few places. So let's see what's going on. 120 is 90 and 30 more. This reference angle is going to be 60. Let's see, this is 1, 2, square root of 3. Since this is to the left, it's minus. And since the square root of 3 is going up, it's positive. 135, that's 90 and 45 more. So the rest of that angle is 45. 1, 1, square root of 2, that's negative. And this angle is 135. So first, the sine of 120 is opposite over hypotenuse times the cosine of 135. Cosine is adjacent over hypotenuse, which is negative 1 over square root of 2, excuse me. It's negative 1 over square root of 2, plus the sine of 135. The sine of 135 is 1 over square root of 2. The cosine of 120 is negative 1 over the square root of 2. The cosine of 120 is still negative 1 over the square root of 2. The cosine of 135, well, that's exactly what's above it. That is, it's negative 1 over square root of 2. And minus the sine of 120 is negative 1/2, and the sine of 135 is 1 over the square root of 2. Okay, let's work this out. This product is negative the square root of 3 over 2 square root of 2. This minus will make this subtraction, and this product is 1/2. In the bottom, negative times negative is positive, and our product is 1/2. I can change both of these, and I get 1 over 2 square root of 2. The LCM is 2 square root of 2. Now multiply the top and the bottom by that. Equals. This product is just going to be negative square root of 3 minus this product, square root of 2, over this product, square root of 2, plus this product is 1. Here is the exact answer to the tangent of 225. It is the exact answer, no rounding off, no anything. You need to know this table. You need to know this table if you're going to have to do a lot of problems. If you're going to have a test that has 5 or 6 of these problems, I would use the table. If I only had to figure out one of them, let me see which one. Okay, if I had to figure out, the sine of 75 degrees. Rather than now, this is the only one. I'll admit, rather than spending a few minutes writing this down, I think, can I get 75? Can I get 75? And maybe I'll think of 30 plus 45. Okay, maybe instead I'll think of 135 minus 60. Okay, if you only have one. But if you have a half dozen of them, I really think you need the chart. Okay, this finishes this section, addition and subtraction rules.